Okay, guys, in this lesson, we're going to learn how to estimate and compare square roots, especially those square roots that are not perfect squares. So a radical expression contains a root. Now, this can be a square root where you have multiplied a number by itself 2 times, or it can be a cube root where you've multiplied a number 3 times by itself, or a fourth root, and so on. So with a square root here, we're asking what number was multiplied by itself to get 16, and we know that that is going to be 4. So the square root of 16 is 4. To take the cube root of a number, you're thinking what number was multiplied by itself 3 times to give me the 27? And that's going to be 3. 3 times 3 times 3 is 27. And then the fourth root, what number is multiplied by itself 4 times to give us 81? And this is going to be 3 as well. 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. Now let's look at the parts of a radical. We have your coefficient that's just multiplied on the outside. We have our index, which tells us how many times the number was multiplied itself to get the radicand. And then the radicand is the number or expression underneath the radical. Now this symbol is the radical. And we can call this entire expression a radical expression. So perfect squares are the squares of a number, the product of multiplying a number times itself. So example, the square of 7 is 49 because 7 times 7, or 7 squared, is 49. So squaring a number creates a power of 2. So 49 is a perfect squared number. The inverse operation of squaring, or raising a number or expression to the power of 2, is taking the square root. And that is what we're going to be doing in this lesson, taking the square root of a number that's already been squared. So square roots are radical expressions that have the index of 2. That means the number underneath the radical was multiplied by itself 2 times. But many times when we write the square root of a number, we don't indicate the index and we leave it blank. So if it's blank right here, if there's no little index number, it is understood to be a 2, and we're taking the square root and not the third root, the fourth root, and so on. So taking the square root of a number gives us back that number that was multiplied by itself. So when we take the square root of 25, we're going to get 5. This was the root that we used to multiply by itself to give us 25. So let's ask the question, can a negative number squared ever equal a positive number? And their answer is no. So this means there can never be a negative radicand for a square root, meaning we multiplied it twice. Because if we have like negative 5 times negative 5, we would get a positive 25. So this number can never be a negative number. So what's going to help is memorizing your perfect squares. That is going to be crucial for this lesson. So I want you to pause the video and I want you to do the perfect squares. It only shows to 15 squared, but I want you to go from the first 20 perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. So pause the video, and then when we come back, we'll go over the rest. Okay, so 4 squared is 16, 5 squared is 25, then we have 36 is a perfect squared number, 49, 64, got ahead of myself, 81, we have 100, we have 121, 144, 169, 196, 225, and then I'm just going to go ahead over here, and 16 squared is going to be 256, And then 17 squared is 289. And then we have 324, 361, and 400. So these are the numbers you need to have memorized. Okay, let's find the square root of each of these numbers. So taking the square root undoes something that was squared. So how did we get 121? Well, we really had 11 squared, which is 121. So taking the square root undoes that, and it gives us back the base of 11. The square root of 196 is going to be 14 because it really was 14 squared. And when I take the square root, it gives me back the base. If we had 225, we really would have had 15 times 15, and taking the square root undoes squaring. The square root of 144. Now here we have a coefficient, so order of operations says take the square root first, kind of like parentheses, and then you multiply by the coefficient. It's going to be 2 times, and this was 12 times 12, or 12 squared. So the square root of 144 is 12, and 12 times this 2 is 24. Here we have 64, and we can write it as 8 squared, and we take the square root of 8 squared, and we get 8, and 8 times 3 is 24. 100 can be rewritten as 10 squared. We get 10 times negative 2, that's negative 20. And now we have 1/2. 324 is 18 squared. Again, I know my perfect square, so it makes life easy. We're going to take the square root, and we have 18 times 1/2. Multiplying 1/2 is the same as dividing by 2, so we get 9. Here we have 1/3 times 9 squared. The square root of 9 is 3, and 3 times 1/3 is the same as saying 3 divided by 3 gives us 1. And then we have 1/4 times 400 squared is really, 400 is really 20 squared. So that's going to give us 20 times 1/4, multiplying by 1/4 is dividing by 4, so that gives us 5. So all these were perfect squares, so I had no radical left. Okay, now let's talk about taking the square root of a number that's not perfect. So we're really going to be squeezing the square root of 12 in between the two perfect squares that we locate on our number line. So let's take a look at the number line. Okay, the square root of 1 is really 1. The square root of 4 is really 2. The square root of 9 is really 3, and so forth. So you can see all the square roots in between, like the square root of 2, the square root of 3, the square root of 5, the square root of 6, and so forth. These are not perfect, so they're going to fall in between two integers. And then we're going to estimate with a decimal. So let's take a look at this. Let me get the select, if it will. So we're going to move this, the square root of 12, and we're going to sandwich it in between the two perfect squares that it falls between. So the square root of 12 is going to fall somewhere right here between the square root of 9 and the square root of 16. So the square root of 12 is going to be between 3 and 4, so like 3 point something. Okay, so we're going to get an estimate. Okay, so that is the first step. So we know that the square root of 12 is going to be right here, falls right here, and we know that this is going to be between the square root of 9 and the square root of 16. So the square root of 12 comes somewhere in between here. The square root of 12 is more than the square root of 9, but less than the square root of 16. So really, it's going to be between the integer 3 and 4. Like I said, it's going to be 3 point something. So here we have 3 point something. So now we are going to determine the fraction part and then turn it to a decimal. So the first thing we're going to do is determine the range between the first and the second number. So between the square root of 9 and the square root of 12 is a change of 3. Then we're going to find the range from the two perfect squared numbers. So here's our numerator. So we're going to have 3 for a whole number, and then 3 is our numerator. And then to get the denominator of our mixed fraction, from 9 to 16 is 7. So we have 3 3/7, but we want it as a decimal. So we're going to convert it to a decimal by dividing 3 divided by 7, or 7 divided into 3. I always remind students it's the top goes in the box. So we're going to have 3 in the box. So we're dividing 7 into 3. We notice 7 goes into 3 0 times. So this forces a decimal. So 7 into 30 goes about 4 times. And we're just going to go out to the 100th and round to the 10th always, for the most part. We subtract, bring a 0 down, and 7 into 20 almost 3 times, but not quite. So we're going to say 0.42. So it's 3 42 hundredths, and we're just going to round and say 3.4. The square root of 12 is about, so we're going to use the about, the approximate. 3.4 is a decimal. Okay, so then we're going to plot this. So about 3.4, and let's change colors right quick. About 3.4, here's 3.5. So 3.4 is about right here, and we're going to say the square root of 12 is about right there. Okay, let's do 30, the square root of 30. The square root of 30 falls between 25 and 36. So we have the square root of 25, which is perfect. We have our square root of 30. So square root of 30 is sandwiched in between the square root of 25 and the square root of 36. And I'm going to switch back colors right quick. And so our two whole numbers is going to be between 5 and 6. So somewhere between 5 and 6, we can see on the number line, is the square root of 30. So now to find the decimal part, so we're going to have 5 as our whole number. We're going to find the numerator. And so from 25 to 30 is 5. And then from 25 to 36 is a range of 11. So 5/11ths. And now we're going to convert the fraction into our decimal part. So the top goes in the box. So 11 goes into 5 0 times, forcing a decimal. 11 goes into 50 about 4, and then that gives us 44. We're going to subtract, bring down a 0, and 11 into 60 about 5 times. So the square root of 30 is about 5 point, and it's 4 5, so we're round up to the half. So about right here is the square root of 30. Okay, let's do the square root of 72. The square root of 72 falls in between the square root of 64, so somewhere right here between 64 and 81. So we have the square root of 64, and we're sandwiching it between the square root of 72, between the square root of 64 and the square root of 81. So our whole number is going to be between 8 and 9. So we're going to have 8 point something. Okay. Now, to get the something part, our numerator is always the change from our first to the second number. So from 64 to 72, it's going to be 8. And then from 64 to 81, that's going to be, 17. Okay, so 8/17. Shouldn't put my decimal yet. Ignore that. So top goes in the box. We're going to have 17 divided into 8. 0 times, force a decimal, 17 into 8. If this were 20, I would say about 4. Let's see if 4 works. 4 times 7 is 28. 4 times 1 plus 2 is 6. When we subtract this, we are going to get, what, 12? Yep, that works, and bring down the 0. Now 17 into 120. Let's try 6, but it may be 7. 6 times 7 is 42. 6 times 1 plus 4 is 100. And so when I subtract that, that gives me, looks like 18, which is a little bit more than that. So we could have bumped this up to 4.7. But nonetheless, we know that this is 5 or more. So we're going to bump this 0.4 to a 5. So we have the square root of 72 is about 8.5. So right in the middle, and it's about that, okay? Okay, the square root of 6. is going to be between right here. The square root of 6 comes between the square root of 4 and the square root of 9. And then our whole number is going to be 2 point something. It comes between 2 and 3. So we're going to have 2. Now to get the something, we find our numerator. That's going to be 2. And then from 4 to 9, that's going to be a change of 5. The top goes in the box, so put the 2 in the box. 5 goes into 2 0 times. 5 into 20 is 4. Next exactly 4, so we're just going to stop there. So the square root of 6 is about 2.4. So this would be right in the middle. So 2.4 is going to be about right here. The square root of 42 is going to fall between 36 and 49. So the whole number is going to be between 6 and 7. So our whole number is 6. The numerator from 36 to 42 is 6. And then from 36 to 49, that's going to be 9 and then 4. So that looks like 13. And the top goes in the box. So 13 divided into 6. And then 13, let's see about how many times. If it were 15, it would be 4. So 4 times 3 is 12. And 4 times 1 plus 1 is 5. And subtract, we get 8. Bring down the 80. Let's see. If we do 5 times, that's going to be 15. 6. And then when I subtract that, that's going to be 15. So we could have gone one more and made this a 6. Again, we just need this to tell us if we're going to round this 4 up to a 5 or leave it the same. We're going to round it up. So the square root of 42 is about 6.5. So about right here in the middle. That's the square root of 42. It's about that. Okay, now let's compare some numbers. So we're going to have to estimate our square root of 5, and we're going to go ahead, I'm going to go ahead and divide this out. So 3 divides into 7. It goes 3 goes into 7, 2. 2 times 3 is 6. We're going to subtract. We're going to have a decimal, bring down a 0, and 3 goes into 10 about 3 times. So far we can stop right there. We may need to go further depending on how this approximates. So the square root of 5 is going to be between the square root of 4 and the square root of 9. Remember, our perfect squares here. So this is going to be 2 point something. And so because it's between 2 and 3, so let's find our fraction. So from 4 to 5 is 1, and from 4 to 9 is a distance of 5. And then we're going to divide 5 into 1. Okay, so we have 0.2. We can stop there because this is 2.3. So we have 2.3 compared to about 2.2. So we're going to say 7/3 is greater than the square root of 5. Okay, the square root of 18. So 18 comes between the 16 and the 25. So we're going to have 4 point something. So from 16 to 18 is 2. And then from 16 to 25 is 9. We're going to divide 9 into 2. 9 into 20 goes 2 times. And we would have another 20, so it'd be 0.2 repeating. So 18 is about 4.2 repeating. Now 5 divides into 24, almost 5 whole times, but not quite. 4 times 5 is 20. I'm going to bring down a decimal. And then 5 into 40 is going to be 8. So this is 4.8. So we have the square root of 18 is less than 24/5. Okay, 4 into 27, the top goes in the box. 4 into 27 goes, let's see, almost 7 whole times, but not quite. That's going to be 24. We're going to subtract and bring down a 0. And so 4 into 30 is about 7. We'll see if that's enough. We may need to go further. The square root of 44 is sandwiched in between. So 44, that would be 36 is a perfect square, and then 49. Okay, so right between. So it's going to be 6 point something. And so from 36 to 44 is a change of 8. And from 36 to 49 is going to be 13. So top goes in the box. So 13 into 80. Let's try 7. 7 times 3, that's 21. Oops, a bit over. So let's erase that. This is what you just do. You just try it out. So let's go down to 6. 6 times 3 is 18. And that gives us 6 plus 1 is 7. Okay, so we can stop there because we can see that this is 6.7, where this is about 6. Right, here's your whole number, 0.6. So this is greater than. The square root of 56. So 56, I'm thinking of my perfect squares. So we have 36, 49, 64. So between the square root of 49 and 64 is 56. So this is 7. From 49 to 56, that's going to be 7. And from 49 to 64, that would be 15, I believe. So if we go up to 50, that's a change of 1. And then from 50 to 60 is, yeah, okay. So 15, so let's divide 15. 15 into 7, this 7 right here. And let's see, B4, B6, let's try 4. That gives me 20, and that gives me, yep, and then subtract. And then we'll see if we need this. So far, this is 7.4. We'll see if we need to go further. And 3 into 22, it goes 7 times. Subtract, decimal, 0, 3, that goes 3. Okay, so that is enough, 7.3, and it keeps going, but we see this is greater than 22 thirds.